Before you write a single line of code, you need to think like a computer. In this video, I'll show you how flowcharting helps you visualize your program, structure your logic, and easily connect your ideas into working code. Welcome to Applied Intelligence, where intelligence is applied, not just learned. Flowchart is a visual representation of a process or of an algorithm. We define algorithm as a step-by-step process or way to solve a specific problem, which can be expressed using natural language or pseudocode or flowcharts. Now, instead of writing code immediately, you have to map out the steps using symbols and arrows before you make a program. So think of it as a blueprint before building a house. So each symbol represents a specific action. And what are these standard flowcharting symbols? We have number one, oval. So when you start and end your flowchart, you use the oval. This is oval for the start and end. Next is you have the parallelogram. The parallelogram is being used for input or output. Then 3, it's the processing symbol. We use rectangle. Rectangle is used for processing. Then we have the diamond. This is for decision making, which has Boolean values, true and false. Diamond for decision making. Then we have the flow lines or the arrows to connect all the symbols, to make it logically connected to each other. So we need the arrows for the connection. So these are the basic flowcharting symbols. Let us start with a sequence. The first, control structure. Example, you're asked to draw a flowchart to compute for the area of a circle using the following variables. For area, we have A. Then we have for the pi, we'll use the pi. Then for the radius, we can just simply put there times r for the radius times r. So we'll be using this formula later on, which pi will give you the value 3.1416. Now, let us draw the flowchart representation for this problem. Let us start with the oval. This is used for the start. So and then what is next? No, so we have there. We can actually initialize or set value for the PI using the processing symbol rectangle. Why? Because we are assigning a value. So there is an action happening there. So assigning value PI or 3.1416 to PI. So we can set that first before we do the input. So what will be our input here? Our input is the radius. There you are. The radius. That will be our input. And then input, process. So we process now the formula. How are we going to compute for the area of a circle? So given the formula, A is equal to PI times R times R. And then output. So input, process, and then output. This is sequence control structure. As simple as that. Then we can output the area. Now, as I mentioned a while ago, you start with this oval and also with the oval. So this is a simple structure for sequence control structure. Let us proceed to selection. Control structure, then we are going to have an example and draw the flow chart, and then you can be able to see the structure, no, for the selection control structure. And then in my previous videos, I discussed there about the inclusion of the diamond decision-making symbol in this control structure. So let's have example. Let's say you are asked to draw a flow chart to determine whether a number is an even number, whether a number is even or odd. So how do we determine a number if a number is an even number? So we're going to get the division, we'll divide it. So everything, all numbers that are divisible by 2, that is an even number. So we are going to divide, and then whatever the remainder, if the remainder is 0, therefore we can say that the number is an even number. So we can make use of the formula, like for example, a num. We divide the num or get the modulo of 2. Okay, this term as modulo or remainder. Okay, we divide or we get the remainder of modulo of 2, and then it will test whether this is equal to 0. No, if that is equal to 0, therefore, so that is an even number. So let us draw the flow chart. So start. Now we have the input. This time, let's make use of the variable num for the input. So we have an input already, no? Let's say, for example, our input is 10. No? Later on, let's determine whether that 10 is an even number or not. Then, we are now going to test whether the num modulo of 2. So 10 divided by 2. Then take the module, the remainder. If the remainder is equal to 0, if it is true, Therefore, you're going to output the word even. The number is even number. Or else, if it is false, meaning that is the number is odd number. Then we go to this direction. Oftentimes, what we do is the top to bottom, not top-down design. It's better this way so that it is logically connected and then easy for you to analyze or understand what is being, how to solve the given problem. Okay, so let us simulate. For example, if the number is 10, so 10, so you get the modulo. So 10 divided by 2, so that is 5 times 10, 5 times 2 is equal to 10. This is 0. So 0, as you can see, this is the remainder or the modulo. So num modulo of 2, is it equal to 0? The answer is true. So therefore, we output the word even. Now, for example, another one. This is, for example, 11. No? So, for example, this is 11. 11 divided by 2. So you have there 5 times 2, you have 10, you have 1 here. So as you can see, the remainder, this is the modulo, as you can see, that is not equal to 0. 1 is not equal to 0. So therefore, we go to this direction, the false direction, and output the word add. And the third one is, let's have an example this time for the loop. For the loop control structure. Let's say you are going to draw a flowchart to output the following on the screen. Let us just have this example first. To output the following on the screen. And these are numbers 3, 6, 9, 12, 15. Okay, so let's have this. So again, so we have 1, 2, 3, 4, 5 numbers to be outputted. Now we can initialize again the value, a certain variable x to your 3 so that we can be able to output immediately 3 on the screen. Now, how are we going to draw a flowchart solving this problem? So again, we start with this symbol. Now, since we don't have the output, or rather input there, so we proceed with setting the value. No? Initializing the value can have like x, can say x is equal to 3. Okay, we'll be using that to formulate a formula in order for us to output 6, 9, 12, and 15. Then next is, I mentioned this in my previous videos, now that you are going to initialize the value, a value for your counter. So there is a counter. Let's say I will name my counter as counter I, no, which is equal, for example, to 1. That also can be equal to 0. But, you know, depending on later on with the decision making. So you can change that to 0, then change something in the decision making. So now let's take that as 1. So let us now test whether the I is it less than or equal to how many values, how many numbers. So we have 5. So therefore, that will loop 5 times. The iterations is equal to 5. So if it is true, if it is less than 5, what will be happening? Now, you started here with 1, but you can also start with 0. But you take the equal sign here, now for the testing, if you would like to start at 0 value, initialize at 0. But in this case, we initialize at 1. So let's take this out. So if it is true, what will happen? So you can now output the value immediately, the value of x. There you are. Now x. And then what is next to x? That will be now the formula. Okay, that will be the formula. Now, how are you going to output 6, 9, 12, and 15? As you can see, the difference is 3. So, you can just simply put there, x is equal to x plus 3. That's how you formulate. Then, what is next to this? We update. So, we update the counter. So, we say I plus plus. And then, of course, that is equivalent to I is equal to I plus 1. You're adding 1. Increment by 1. And then, before it loops, so it will loop now and then pointed back to here. Okay? And then, until such, it's true, so that will be executed. But once it is not less than anymore or equal to 5, if it is false, so that will be now the end of the flowchart. Let us do the simulation for this flowchart. So let us simulate to test also whether our flowchart is correct. So we can have x is equal to 3, I is equal to 1. Then we proceed to this testing. Let's say that will be your first pass or pass 1. That is just labeling. So I1, is it less than or equal to 5? So that is true. So that is true. So meaning we go to this side, output the value of x. So let us draw a box for output representation. So let's have x. The value of x is, there you are, 3. Or there, 3. Then what is next? X is equal to x plus 3. So what is the value of x? 3 plus 3. X now is equal to 6. And then the next instruction is I increment. No? So we increment the I to 2. Then look at the arrow. Look at that. So it goes to the testing again. So let's say that will be the second iteration. So let's go to the testing. I, what is the value of I? That is 2. Is it less than or equal to 5? Then that is true. Then go to this. Output the value of x. So what is the present value of x? That is 6. Okay, so then we compute x is equal to x plus 3. The present value of x is 6. Plus 3, x now is 9. And then increment the value of I to 3. Then again, loop. And then test. So we are now on our third iteration. So pass 3, and then you say I, which is the value, which has a value of 3. Is it less than or equal to 5? Which is true. Proceed to the true side. Output the value of x. The value of x is 9. And then proceed to the next instruction that says x is equal to x plus 3. The present value of x is 9 plus 3. X now is equal to 12. Then we increment I. This time is 4. Then we loop. Then we are now in pass 4. So test again. I. What is the present value of I? 4. Is it less than or equal to 5? That is true. Output the value of x. What is the value of x? That is 12. And then what is the next instruction? Saying x is equal to x plus 3. What is x? 12 plus 3. That is now x equal to 15. And then increment I is still equal to 5. Then go back. You test 5, is it less than or equal to 5? So we are now at our last iteration. So asking 5, is it less than or equal to 5? That is still true. Then output the value of x. The value of x, there you are, 15. And then you look back. Then again, you proceed to this. So asking like, how you update first the I. I now is equal to 6. Then loop, is 6 now? Is it less than or equal to 5? The answer is false. That's the end of the flowchart. Before you code, design. Before you type, think. If you found this helpful, don't forget to like, share, and follow for more tutorials. This is Applied Intelligence, where intelligence is applied, not just learned.